Hello everyone. So today we will see Singleton design pattern. This is also one of the creational design patterns which revolves around how to create an instance of an object. So Singleton design pattern restricts the instantiation of a class to one object. So in what scenarios we might need this? So we might need this for DB connection, logger, to have some config manager which will have one instance and load the configurations, or we can have it for error manager. So we will see various examples on how we can achieve this. We will also see how we can break this pattern and also how to overcome such scenarios. So watch till the end, you're going to get a lot of knowledge through this video. So there are basically three important things for any singleton class. The first one being we need to have a private static variable which will hold the instance of the class. Okay, the second one is the private constructor so that other classes do not instantiate this class. And the third one being the public static method which will return the instance of the class. So this method will check if the instance is existing or not already, and if it is null then only it would create the instance and it would return the instance. So this is a very basic example of singleton. So in the next example we will see that we can also have an eager initialization. So that means we are not checking whether the instance is null or not, but we are going to create an instance when the class itself is loaded by the JVM. Okay, so in this static instance variable only we will create the instance of the class. So when this class is loaded by the JVM, the instance also is created. So when the other classes call this getInstance method, we will return that instance. So in case of a multi-threaded scenario, what could happen is this if condition. So one thread might be checking the if condition, the other thread might be creating the instance. So in that case, what we can do is we can use this synchronized keyword so that the thread has to take the lock of the class first, and then only it will do this check and then create the instance. So till that time the other threads have to wait to get the lock and then only they can execute this method. But the drawback of this is utilizes the resources. So to avoid the resource utilization in the previous example, what we can do is we can use a double checked singleton. So in this pattern, what we do is, so we are going to use synchronized in the if block. Okay. So suppose if the instance is not null, then we don't need the synchronized, right? We don't need to lock the object every time. So only if it is null, then we are going to go inside this if block and then lock it. Otherwise, we will directly return the instance. So in multi-threaded environment, threads don't need to wait if the instance is already existing. Only initially when it is null, then only we will go and then lock the provide the synchronized block wherein the threads will take the lock of this class, and then what we are doing is we are doing a double check. Okay. So once we get the lock, we are again going to check if the instance is still null, because this first if block is not thread safe, right? It is not synchronized. So by the time we get the lock, there might be other thread which has already created the instance. So here we will double check if the instance is still null. Okay, if the instance is still null, we are going to create the instance. And also one point to note here is the volatile. We are going to use this volatile and we will make this null, because what happens is, so one thread is, suppose it has taken the lock and it is creating the instance and it will assign. So what the JVM does is it might not immediately assign the actual instance to this variable. Okay. So when the other threads come and check that this is not null, they might get this instance, but this instance is actually not pointing to the object. Okay. If we are not using volatile, what happens is the JVM will rearrange the operations, the right operations. So it might assign the variable, but the actual object is not yet present in the memory. Okay, so that is why if we use volatile, what happens is volatile means it will get directly from the memory. So the JVM will not do any rearrangements in the way it's assigning the variable and creating the actual object. So in that case, if it is volatile, then it is sure that if it is not null, then the instance is present. It is already mapped to the proper instance in the memory. Okay. So in double checked singleton, this volatile is very crucial. And also the synchronized block within the if block, and we are going to double check whether the instance is still null or not. So if you are aware of reflection, you know that we can get the constructor and change its private to accessible, and then we can access the constructor of the class and then create the instance. So if you're not aware of the reflection API, go and check my video. I'll give the link in the somewhere in the video. Here you can watch it. Okay, and then yeah, so in that case, what happens is with reflection, we can break the singleton pattern. So to avoid that, when we want to create the singleton, we can use it in the form of an enum. Okay, so for enum, Java internally handles that it will only create the instance. It will not let others create the instance. So like we cannot create any instance of enum, right? So Java itself handles that. So reflection will not break our singleton here. The drawback for this is the instance would be created eagerly. It would not be a lazy initialization. When the enum is loaded, the instance would be created for that singleton. So another way to break the singleton pattern is by serializable. Okay, so if our singleton is serializable, or if any of its superclass in the hierarchy is serializable, then what happens is once we serialize it in the form of a file, and then again if we deserialize it, so and then when we try to get the object, so we might not have the same instance. So to handle that scenario, what we can do is we can create this, we can override this read resolve method, because this is the method that gets triggered when we deserialize it. So in this read resolve method, we are again going to call the instance, which will return the same old instance which is present in the memory. Okay. So our class might implement serializable, or any superclass might be implementing serializable. So it is better to have this protected read resolve method implemented to avoid all such scenarios. And another way to break singleton is, suppose if our superclass was implementing clonable. Okay, so we can clone the subclass. If our subclass has to be singleton, we can clone it and we can get another instance. So that would not be a big deal. So in that, so if you see here, we have this superclass. So this is a clonable superclass. Okay. So now we are extending this class. So even though our singleton class is not implementing this clonable, but its superclass does. So even in such scenarios, the other classes will be able to clone and create another instance of our singleton, which we do not want. So in that scenarios, what we can do is we can override that clone method, which might be used to create the new instance. And instead of providing the clone, what we can do is we will throw some clone not supported exception, so that by all scenarios we are trying to make our singleton as a singleton. So if you like this video, do hit the like button and subscribe to my channel, and also hit the bell icon to get the notification for the next video. Thanks for watching.